Cross-validation. Problem statement. A few learners have implemented random forest classifier on the iris data, but better accuracy can be achieved by using the cross-validation sampling technique. In this analysis, we will generate the random forest using the cross-validation splitting technique. Let us import the inbuilt iris dataset from the sklearn.datasets library. From sklearn.datasets, import load_iris. Load the dataset with a data frame. Extract the input data. Similarly, extract the target values. K-fold cross-validation. Use the K-fold cross-validation technique to split the dataset into K consecutive folds without shuffling by default. Here, we will split the dataset into 5 consecutive groups. From sklearn.model_selection, import K-fold. Using a for loop, we will now iterate the individual train test sets within the input data. Let's now split the data set into 10 consecutive folds. Using a for loop, we will now iterate the individual train test sets within the output data. Let's initialize the random forest classifier. From sklearn.ensemble, import random forest classifier. Import the cross-validation score library from sklearn and get the model evaluated for accuracy by using the cross-validation score parameter. From sklearn.model_selection, import cross_val_score. The accuracy of the classifier is 95. Great, we have seen how to apply cross-validation to split the dataset. Let's quickly recap the steps we covered. 1. Shuffle and split the dataset randomly into K groups. 2. Summarize the skill of the model using model evaluation scores. This brings us to the end of Ensemble Learning. You are now able to explain Ensemble Learning, evaluate the performance of boosting models,